Hello everybody, enrichment time through integration. Further maths, and we have to do this definite integral. The integral from 0 to root 3, the square root of x plus the square root of x squared plus 1 dx. And to show, we have to actually show that this integral is equal to that. Okay, first of all, I want to say something. I didn't actually mention it yet. Not this particular question, but a variant of that, without limits, was put to me by one of my students, Albert, that is. It'll come as a surprise to him when he sees this video the other day. So I thought to myself, I'll make a question, a little variant. Only this is a lot harder with the manipulations that are required to sort out these limits. And let's see how it goes. This is going to be quite disgusting. I think there's more work to actually deal with the surds involved in this than to actually do the integral. So we're going to start it and let's see how this will now go. As I said, further maths is required. So how do we approach something like this? Well, the first thing that you should be thinking is possibly a square root substitution. If you try it, you won't go places. Then your mind should be going perhaps trig, because that's 1 plus tan squared, or possibly hyperbolic, because again that's 1 plus sine squared. It's the standard substitutions. I haven't really tried with the limits, the trig one, but I think the trig will also work. If you look at the 0 and root 3, the tan of root 3 is of course pi over 3, so it will sort out some nice numbers. I think actually it might work better with the trig, although today I'm going to do it with hyperbolic substitutions. Okay, so the substitution that I'm going to use, I'm going to write it here, is going to be x is equal to sine of x is equal to the sine of theta. The actual substitution, of course, I'll write it like this for the algebra. I keep saying the same things often. The actual substitution is theta is the r sine of x. Okay, but we want it like that because it's easier. I need my dx. So dx is equal to the cos of theta d theta. And I need to change my limits. When x is equal to 0, the r sine of 0 is in fact 0. And when x is equal to the square root of 3, the theta is the r sine of the square root of 3. I'm going to write it in log form. So the r sine of root 3 is of course equal to the log, using the logarithmic form, of root 3 plus this squared plus 1 under a square root. So that's 3 plus 1 is 4, so it's equal to that. Of course you can check it in your own time. That's the log of 2 plus the square root of 3. So this is the change of the limits. If I need more stuff, I will come there and obtain more. So let's see how this integral now transforms. So it's equal, and this is our target, of course. So the limits will go the log of 2 plus root 3 and 0. And of course, the integrand will simplify massively. We're going to have, of course, a sine of theta plus the square root of sine squared of theta plus 1. Square rooted. And my dx from here is, of course, the cos of theta d theta. Okay, next line from there. Lots of simplifications. Cannot do it here. Probably I can just about fit it in here. So integral from 0 to the log of 2 plus root 3. 1 plus sine squared is of course cos squared, square rooted cos. So inside the square root I will have sine of theta plus the cos of theta, square rooted, and then we got of course a cos of theta d theta outside the square root. This will simplify nicely because of course we're going to switch into exponentials. So that's log of 2 plus root 3. Let me change this pen because this pen is getting very blunt and I don't know if it's visible on the video. Let's change the pen. So now we're going to have the square root there. Sine is of course a half Let me actually write it here, and then I'll write straight the answer there. This is, of course, a half e to the theta minus a half e to the minus theta. That's my sine. And then adding a cosh is, of course, a half e to the theta plus a half e to the minus theta. This will cancel, and I get a whole e to the theta. So under the square root, I will have e to the theta. And maybe I should write the square root to the power of a half. Having done all this, is probably that will be my intention on the next line. So that's the e to the theta. So that's this bit here from there. And the square root, of course, is to the half. And quite clearly, I will switch the cosh, which is outside the square root, also into exponentials. So that's going to be times a half. And the cosh there is going to be e to the theta plus e to the minus theta d theta. So this is actually a very, very easy integration. I did say actually the integration of that is quite straightforward. Once you see the substitution, you're done essentially. You have a bit of work to do if you were to do it, of course, without limits, because you have to go back into x, so a little bit more work. But now putting these limits in there is quite something. Okay, this a half I'm going to put outside the integral. Here it comes. And then I'm going to multiply the bracket. Let me put the log of 2 plus root 3 and 0 at the bottom. This is e to the half theta. Let's write it like this and lose the bracket. Not lose the bracket, lose the a half from there. So we multiply, so e to the half of theta, easier to see. This a half we took care of, it's outside. So it's going to give me e, I'm adding the powers, so that's to the 3 over 2 theta. And then it's plus e, I have half theta, add minus theta is to the minus a half theta d theta. Straightforward integration. And we've got, of course, a half. I'm going to use a square bracket there. This is, of course, exponentials, very simple integrations. E to the 3 over 2 theta with the 2/3 in front of it to make it work. And I've got, of course, e to the minus half theta. And to make it work, I need a negative 2 in front of it. And I need to substitute the limits. 0 to log of 2 plus root 3. And probably before I do that, because I noticed this half will make it a little bit simpler, I'm going to have a third, half times 2/3, e to the 3 over 2 theta. And 2 times a half is, of course, 1 minus e to the minus a half theta. And we have this now between the limits of 0 and log of 2 plus root 3. What do we do next is the question. We need to think a bit about it. It does have an element of beauty, because non-calculator, even the calculator here cannot possibly, I did try it cannot possibly give you this answer. It will just go into decimals if it fails. So you have to be sensible about how you're going to approach it. If you put the log in there, the problem is this 3 over 2 log. And of course, similarly, the minus a half is just as ugly. If you have a 3 over 2 there, okay, you can move the 3 over 2 up here. And then e to the log, it'll give you 2 plus root 3 to the power of 3 over 2. I don't think I fancy getting from there to this line, or things of that that look like this. So I probably need to think smartly. Well, the 0 is not a problem, of course. E to the 0 into the 0 is fine. It's this thing here. So I'm going to put one extra line. So let's make a bit of space and tidy this up before I attempt any limit substitution. So if you look carefully, I've got this, I can factorize an exponential. So, and I can factorize this a third as well. That is ugly as it is in there. So I'm going to say this is a third. And I'm going to factorize the lowest power, which is e to the minus half theta, because at least I'll get an integer power for my or argument, if you want, for this exponential. So if I do this, what's going to happen? This is not the square bracket for the evaluation. I still haven't put this bracket in there yet. I got the third pulled out. It's going to leave me an e to the 2 theta. Adding this will give you your 3 over 2 and the third. Then I'll have a minus. And from here, I pulled all of this out. So I got a minus 3. And now all of this is inside the evaluation square brackets, which is 0 and the log of 2 plus root 3. Why did I do that? It's, well, quite obvious. It's not too bad to put this log here, and at least I have less sort of hassle, because I lost that 3 over 2, because that's cubic and square rooting is not something I particularly want to do. So at least with the square root, I might be able to cope better. Okay, normally I will be carrying on the workings from here. I'll be saying equal, put these numbers, equal, equal, equal. And when I was actually doing the question, when I was making the question, I did do that, but it became very, very messy trying to follow all of this. So I'm actually going to work out each quantity separately. Evaluating obviously at 0 is not a problem. I'm going to substitute, first of all, the log of 2 plus root 3 into this quantity. So I have a simplified answer for this. Then I'm going to put the log of 2 plus root 3 into this quantity here. So I have it ready. And then I'm going to put everything in at the very end. So now I'm coming out of the workings and I'm opening up a shop where I'm going to do all my bits and pieces. So first of all, e to the minus a half. I'm going to see what happens to this term here when I put log of 2 plus root 3. So that is equal to the log of 2 plus the square root of 3. I would like to get rid of this, so I need to lose the minus a half quite clearly. So that goes to the minus a half, and at least I will have now e to the log, so this will release this particular quantity. So I have, shall I write it as 1 over perhaps the square root of 2 plus the square root of 3. So this is that quantity, e to the log, of course, the inverse operations, and 2 plus root 3 to the minus a half is the square root of this at the bottom. Now, quite clearly, I have a problem. I've got the square root of a square root, and this will never go to look like this unless I simplify this mess. So what can I do there to perhaps simplify this? There is a way of finding square roots, but I can see I have a problem here. Perhaps expressions such as something square root of 3 plus a constant all squared. So this is basically this bit here is identical to 2 plus root 3 is the normal way of doing square roots and square root of a square root. I don't know if you've seen things like that, but this is not the case because I got in my answer 2 root 2. So this cannot possibly be of this form. So, and I did try it, of course, when I was doing the work, and of course it failed. So I tried something else. So this is what I tried in my approach and in my solution. I said, and of course there might be other variants of that, so I'll be interested to see if anybody found anything different and perhaps more efficient to what I'm going to show you. I'm going to first of all multiply top and bottom of this fraction by the square root of 2 plus the square root of 3. So if I times top and bottom by this will open the outer square root, because of course that'll go squared times another one of these, and the square root will go to the top. And then what I can do next perhaps is to rationalize the denominator, because I spot that 2 squared minus the square root of 3 or squared is 1, so at least I won't have a fraction. So that seems like a good idea at the moment. So square root of 2 plus the square root of 3 multiplying by the conjugate, the radical conjugate of this, so 2 minus root 3, and of course that'll give me 4 minus 3. So that's a 1, and that's why I've done what I've done in there. So the question now is, now what? Okay, in this particular case, so let's tidy this up. 2 minus root 3 multiplying the square root of 2 plus the square root of 3. Okay, this doesn't look pretty, does it? I can of course multiply inside the bracket, so I'm going to perhaps manipulate it a little bit, because I'm thinking perhaps I can factorize something out of this and create perhaps a perfect square on the top. And what I'm thinking in there is to write this as 2 minus root 3 and multiply top and bottom of this particular fraction, which of course, each of them rather, you can do it as a whole over 1, but you can treat them separately. So I'm going to make a 4, so this will become now a 8 over 4 there, and the root 3 will become a root 3 over 4. And the reason I picked 4 is because I know that root 2 is a little bit difficult actually to explain. It's just experience, I suppose, of and having seen a lot of things before. First of all, in order to square root of that, and I know it's not just the square root of 3 in there, there's other numbers. The root 3 and the root 2 make a root 6. And by doing this, I created this 8. And of course, it's very, very difficult, as I said, to explain what's going through my head at the moment. I'm thinking of these two quantities. Okay, the square root of 6 all squared and the square root of 2 all squared, it'll give me 6 plus 2, which is the 8. So I'm trying to create an 8, and I have, of course, the added benefit that I have quarters there now, so the quarters can factorize out of the third. So a little bit difficult, a bit of experience, perhaps a little bit of pot luck sometimes when you're trying things. You need to hit to be a bit lucky sometimes what you're trying. Okay, so this is 2 minus root 3. Factorize the quarter out of the third, so that's going to be a half. This is the quarter, and in there I have 8 plus the square root of 3. And now this is what's happening there. Sorry, I missed the 4 there. Multiply top and bottom by 4, so it should be 4 root 3 there. Silly mistake. If somebody finds the cure for stupidity, please let me know, because I do a lot of stupid things. So I'm going to move it a little bit higher up. So here we go. All right, so this is not a problem. The beginning of it is fine. It's merely being copied. A half 2 minus root 3. And now the question is, what is this thing here? Square root probably better. I don't need a bracket. 8 plus 4 root 3. I'm going to go with my original plan. And of course, what makes me think about this is also the form of the answer. So root 6 all squared plus root 2 all squared. This is my 8 that I've got in there now. Okay, so if I square these two quantities, if I was squaring root 6 plus root 2 all squared, I'll be getting square the first thing 6, square the second thing 2. Multiply them together and then double your answer. So plus 2 lots of the square root of 12. And the 2 lots of the square root of 12, I hope we can all see, is in fact 2 times another 2, 4 root 3. So 8 plus 4 root 3. That's exactly what I've got in here. It's exactly this quantity that I've got up there. So I've done the workings up there. I don't want to rewrite them again. So I'm going to say this is equal to a half 2 minus root 3. And this now, the argument of this particular square root is going to be the square root of 6 plus the square root of 2, and it's all squared. Okay, and of course now I managed to square root all these horrible looking things, and the square and the square root can disappear. So I got 2 minus root 3 multiplying just simply root 6 plus root 2. And now my simplification to follow. So that's a half. Multiply the brackets, it'll be tedious now. 2 root 6. We go so far, so let's hope we don't make mistakes now. 2 root 2 minus root 18. And root 18 is 3 root 2. And lastly, we got minus a root 6. Minus root 3 times root 2. And what we'll simplify to is a half. 2 root 6 minus root 6 is simply root 6. And 2 root 2 minus 3 root 2 is minus root 2. Let's think about what we just done. This is in fact the answer to e to the minus a half theta, just this quantity here, when we substitute the log of 2 plus root 3. We need to do a similar thing for this quantity. The minus 3 is not a problem, but I think that's a lot easier. And of course, it's a lot easier because there's no square roots there. It's just a squaring, so it should be okay. I'm going to write this answer. So the e to the minus a half theta evaluated at log 2 plus root 3 produces a half root 6 minus root 2, so I don't lose it. And now the other one to follow. And I think that was the hard bit for this particular evaluation, to actually see all of this. I tried a couple of different things, I couldn't, but eventually I cracked it. As I said, sometimes you need a bit of luck, sometimes a little bit of mathematical gut feeling. It all helps. All right, e to the 2 theta minus 3, when we're substituting that, it's going to be e to the 2 log 2 plus root 3 minus 3. Move the 2 as a power here. Now e to the log will of course disappear, so I'm going to have 2 plus the square root of 3 all squared. This is actually very easy, it's not anything hard. So it's going to be squaring this bracket, which is going to be 4, multiply together and double 4 root 3, and then plus this bit squared, which is plus 3 minus 3. So this cancels in fact. So this is in fact your answer. So when we're evaluating, and let me just write it here, e to the 2 theta minus 3 evaluated again at the log of 2 plus root 3, the answer is simply 4 plus 4 root 3. After that is just plugging the numbers in and coming to the answer. Hopefully, let's do that. And I hope I haven't made any silly errors. Let's lose this now, this blue line. And let's go back to our evaluation. So we're returning to this line here. Putting now log of 2 plus root 3, we're going to have a third from there. This quantity, when putting the log, evaluates to that. So that's times a half root 6 minus root 2 from up there. So then we have another bracket, which is this quantity, and this quantity also evaluates at the top limit. It's going to be 4. This pen is dead, so let's switch back into the blue pen. I do apologize, multicolored here, this particular question. I'm gonna throw some of these pens away once this lecture is over. 4 plus 4 root 3. So this is all of this evaluated on the top limit from here. And then I go minus the same thing evaluated when theta is equal to 0. So that's going to be a third. E to the 0 is of course 1, I don't need to write it. And e to the 0 is 1 minus 3 is minus 2. So still a bit tidy to do, but that's actually here 12 thirds now. It's nothing of interest really. What shall we do in there? First of all, just let's change that into a positive 2 thirds. So that's easier, plus 2 thirds. And let's multiply perhaps, we got the 4 plus 4 root 3. So let's factorize a 4 out of this bracket. So this will become 1/3. And if we factorize this 4, it will become times 2 bracket root 6 minus root 2. and this will become 1 plus the square root of 3. So the 4 was, when it's gone out, makes this into a 2 plus 2/3, and then maybe I can factorize it 2/3, and now what will be inside the bracket is the product of those two brackets plus the 1 that's been left from the factorization of 2/3 from this term. So let's multiply these brackets. We got root 6 times 1, and then we got root 6 times root 3, which is root 18, which is 3 root 2, and then we got a minus root 2, and then we got minus root 2 times root 3, which is a root 6, and the root 6 is go. And we're going to have, of course, I'm going to write it here, the 2/3 at the front. 3 root 2 take away root 2 is, of course, 2 root 2 plus 1, and we are done. And I hope you enjoyed this particular question. Thank you to Albert for giving me an idea with something like this. And who's laughing now? See you soon.